Hello everyone, I welcome you to today's class. And our topic today will be on matrices. And we'll be starting this series on introduction to matrices. Okay, now let's start with what is matrice? Matrice. Somebody saying what's the difference between matrice and matrices? Matrice is singular. This is singular and this is plural. When you have only one matrix, when you have only one, that is matrix. When you have more than one, it is matrices. So this is plural, this is singular. Okay, matrix is a rectangular, a rectangular. Some people say it's a rectangular array or rectangular arrangement of numbers. Array of numbers. Okay, enclosed within brackets. Okay, when numbers are arranged within brackets, okay, such an arrangement of numbers is known as matrix. Okay, for example, if I have a equals to 1, 2, 3, 4, this arrangement of numbers in this bracket is known as matrix. So this whole bracket, the whole bracket with the numbers are known as matrix. Okay, now let's go further to elements. Let me explain element of matrix. Okay, what do you mean by element of matrix? Now, each numbers in a matrix is known as element of a matrix. Okay, the numbers, that is the numbers in a matrix. The number in a matrix is known as the element of a matrix. Okay, now that shows that one, from this example upstairs, one is an element of matrix A, and this two is an element of matrix B, and so on and so forth. That shows that my 1, my 2, my 3, and my number 4, 1, 2, 3, 4, are all elements of matrix A. Okay? Do you get that one? Good. Now, let's quickly explain what we know about rows and columns of a matrix. Okay? The rows and columns of matrix. Now, rows are the horizontal arrangement of numbers. Okay, the horizontal arrangement of numbers in a matrix is known as the rows of a matrix. Okay, the horizontal arrangement of numbers in a matrix is known as the rows of a matrix, and they are the elements. The element that runs from left to right. Okay, in a matrix. I'll give you an example, don't worry. For example, if you check this, let me use that example. If you check this example of a matrix we have here, we have this matrix which is 1, 2, 3, and 4. This element here is known as row, and that'll be my row 1. This one will be my row 2. Okay, this particular matrix that we have here has 2 rows. Now, the row 1 has 2 elements, and the element is element 1 and 2, and row 2 has 2 elements, which is 3 and 4. Okay, do you understand? Do you get to that point? Perfect. Now, sometimes some matrices can only have only one row. Those matrices that has only one row, they are specially referred to as row matrix. Okay, now row matrix with only one row is known as row matrix. Okay? For example, if I have this kind of example, if a matrix A equals to 1, 2, 3, 4, this kind of matrix is known as row matrix because it has only one row. It may have many columns, but as long as it's having only one row, such matrix is known as row matrix. Do you get it? Now, in our common classes where we're talking about types of matrices, then we explain deeper on row matrix. Do you get it? Perfect. Now let's go to columns of a matrix. Columns. Columns of a matrix. Columns of a matrix is the vertical arrangement of numbers. It is the vertical arrangement. The vertical arrangement of numbers, or the vertical directions. It can be the vertical directions of numbers, or the vertical direction of element. The vertical arrangement or the vertical direction of elements in a matrix. And it is the element that runs from top to bottom, up to down. The element runs from up to down. Okay? The element runs from up to down. Somebody saying, can you just give an example of such? Can you just give an example of such matrix? Okay, I will give an example. Take for instance, if you have this kind of matrix, if you have matrix A equals to 1, 2, 3, 4. Now this is column 1. That is column 1, and this is column 2. This is column 2. The column 1 has 2 elements, which is 1 and 3. And this column 2 has 2 elements, which is 2 and 4. Okay? Same as rows. Some matrices that has only one column are known as column matrix. Okay? And we will also explain this better in our common class. That's why you need to subscribe to my channel and you like my videos, so that now those classes, as they are coming, you'll be able to follow them and you learn better. Thank you so much. Okay, now let me give an example. For example, if I have this kind of element or this kind of matrix, this matrix is an example of column matrix. If I have this 1, 2, 3, 4, this kind of matrix is what? A column matrix. Okay, they are column matrix because they have many rows, but as long as they have one column, as long as there has only one column, such a matrix is known as column matrix. Okay, now please don't mistake this. When you have this kind of matrices, you should be able to identify them, and the identification of these matrices is what we're going to discuss in our common class. Okay, now let's go straight to notations of matrices. Let's go straight to notations of matrices. Okay, now notation of matrices. Okay, notation of matrices. How do you identify matrices? Okay, now matrices can be denoted. Let me write it. Matrices are denoted by bold capital letters, okay, and element of matrix are denoted by small letters, with suffixes, and these suffixes specifies which specifies the position of the element in the matrix. I will explain that, don't worry, in the matrix. Okay. Now, what we are trying to say is matrices are always denoted by capital letters and mostly bold capital letters. For example, you see me writing matrix A equals to, let's say I say A11, A12, A21, A31. This is the way we represent matrices. Now, matrices should be in capital letter or mostly in bold capital letters. Okay? Now, and the element of those matrices can be denoted by small letters. You see small letter A, small letter A. And those small letter A, those small letters, they have suffixes. You see 1, 1, 1, 2, 2, 1, 3, 1. Each of those numbers has a meaning. Those numbers are telling me the position of those elements in the matrix. Okay? Now, what it means is that when I have A, I, J, the suffixes is I and J. Okay? For example, if I have A, I, J. Now that shows that the first suffix is telling me about the rows. And the second number, the second suffix is talking about column. Okay? Do you get it? That shows that this one that you're seeing here is telling me that this first element belongs to row 1, column 1. That shows that when I have my A11, it means this element belongs to first row. It belongs to, let me write it like this. It belongs to row 1, and column 1. Okay? Now that shows that A12, it means that this element belongs to row 1 and column 2. All right? And that shows that this one belongs to row 2, column 1. Let me write it. That shows that my A21 means that that element belongs to row 2 and column 1. Okay? When I have A22, it means that it belongs to row 2 and column 2. Do you get it? Can I go further? Okay, for example, if I have somebody saying, what if we have this? If I have matrix A, if I have matrix A, if I have matrix A, if I have, I'm coming, if I have matrix A, if I have matrix A equals to, what's wrong with this marker? If I have matrix A equals to, this will be A1, 1, this will be A12, this will be A13. Okay, that shows that the first element belongs to row 1, column 1, row 1, column 2, row 1, column 3. Okay, do you get it? Because the first one tells you about the rows and the second tells you about the column. Okay, now let's do some examples about notations of matrices. Let me give an example. If I have a matrix like this, e.g., if I have A equals to 2, 3, 4, 5, 6, 7, and I ask you that what is A 2, 3? What is A23? A subscript 2 and 3. Can you identify A suffix 2, 3? You just go to row 2, column 3. This is row 2, column 3. We have row 1, don't forget we have. This is row 1. This is row 2. Okay? This is row 1. Let me take it further. This is column 1. And this is column 2. And this is column 3. Okay? Now, you now go to row 1. because we're sorry. Can I clean this question so that you'll be able to see it? I was asked that what is A 2, 3? That's where we're going. You now go to row 2. Where's row 2? This is row 2. Don't forget this is row 2. Row 2, you now count, but this is column 3. You go to column 3. Okay? So my A 2, 3 is what? Is 7. And that'll be 7 because this is column 3 and this is row 2. Do you get it? Perfect. Let me do more examples. If you're given this example, if you're given that B equals to 147 minus 1, 0, 8, 3, 8, 5. What is B31? What is B31? Can you tell me B31? It means that what is the element at row 3 and column 1. So you go to row 3, 1, 2, 3. Okay, this is my row 3. Okay, row 3. And I need to go to column 1. Which one is my column 1? This is my column 1. You see it? Where did they meet? They meet at 7. So my B31 is equals to 7. Okay? If you ask, what is your B23, for example, what is your B23? You go to row 2. What is your row 2? Your row 2 is this. This is your row 2. Okay, can I clean this number? I'll clean this number. What is your row 2? This is your row 2. Okay, what is your column 3? This is your column 3. Okay, your column 3, where did they meet? They meet at 8. Okay, that shows your B23, your element at row 2, column 3 will be what? Will be 8. Do you get it? Are you getting it? So this is the way you can identify the position of an element in a matrix. Do you get it? Perfect. All right. Let's go further to the order. Let's go straight to the order of a matrix. The order of a matrix. Order of matrices. Order of matrices. Order of matrices is just only telling us about the number of rows and the number of columns in a matrix. Are you getting me now? Now, since we have been able to explain that there are rows and there are columns in a matrix, so how do we know the orders? Generally, if a matrix has an m rows and n columns, they are called m by n matrix. Okay, now for the order of a matrix, the number of rows come first, followed by the number of columns. I'll give an example. For example, if I have a matrix, e.g., if I have a matrix of, let's say, A equals to 1, 4, 3, 8. What is the order of this matrix? The order of this matrix is 2 by 2 matrix. Why? Because it has 2 rows and 2 columns. Okay, now let me give another example. If I have my B equals to 1, 3, 4. What is the order of this matrix? The order of this matrix is what? 3 by 1 matrix. Okay, it's telling me that it has how many rows? 1, 2, 3. How many columns? 1 column. Okay, now let me give another example. C equals to, if I have matrix of 2, 4, 6, 8. What is the order of this matrix? It is 1 by 3 matrix. How do we get that? How many rows? 1 rows. How many column? 1, 2, 3, 4. Sorry, 1 by 4 rather. 1 by 4 matrix. 1, 2, 3, 4. 1 by 4 matrix, because it has 1 row and 4 columns. Let me do more example because of this mistake here. Okay, if I have a matrix like this, if I have x equals to 2, 4, 6, 7, 3, 8, 1, 0. What is the order of this matrix? The order of this matrix is 2 by 4 matrix. Okay? Because it has 2 rows. How many columns? 1, 2, 3, 4. Do you get it? And so on and so forth. Do you understand the order of a matrix? Okay, let's go. Let's talk about equality of matrix. And probably maybe that's where we're going to end the class today. Now, two matrices are said to be equal when they have the same shape, the same size, and even when all the elements in both matrices are equal. Let me write it. Matrices, or let me say two matrices are equal. Two matrices are equal when they have same size and shape and all the elements in both matrices are the same. Okay, let me give an example. If we have a matrix, if we have a matrix 2, 4, 6, 7, which is equals to 2, 4, 6, 7. If you check, we have 2 here. Let me use another marker to specify that. If I have another element here, we have 2 here in row 1, column 1. For the second matrix, we have 2 here. That is row 1, column 1. We have 4 here, we have 4 here. We have 6 here, we have 6 here. 7 here, 7 here. So that shows these two matrices will be equal. What's the essence of this equality of a matrix? Let's give some example and we solve that. We do many examples in this place. Okay. Assuming that we have this matrix. Examples. Assuming that we're told that if x 4, we have, let's say we have 9, we have y equals to 8, 4, 9, 3. Find x. Number figure 1, x. Number figure 2, find y. And number figure 3, if it has to find s plus y. Let's do it. Now, since we have said two matrices are equal when the elements in those matrices are equal and when they have the same shape, they have the same size. This is 2 by 2 matrix. This is 2 by 2 matrix. Okay, let me explain this. Supposing we have this kind of matrix, we have 2, 3, 4, 6. And we have this matrix, we have 2, 3, 4, 6, 8, 7. These two matrices can never be equal. Why? Because this is 2 by 2. This is 2 by 2 matrix, and this is 2 by 3 matrix. They don't have the same size, so they can never be equal. Do you understand what I'm trying to bring up? So the two matrices can only be equal if their elements are the same and they have the same order, they have the same size, they have the same shape. Okay. Now these two matrices are equal because when you check the element there are the same. This is 9. This is 9. This is 4. This is 4. This is 3. If this is 3, that shows that this y will also be 3. If this is x, that shows this will be 8. Okay. Do you understand what I'm trying to say? Now that shows that my x will be equals to 8. And my second example, my second question is y. Y will be equals to what? Y will be equals to 3. Okay. So my y will be equals to 3. The third question says x plus y. And my x plus y will be 8 plus 3. And that's equals to what? That's equals to 11. Do you get it? Let's do more example. Example 2. If If we are told that we have 2x plus 4 and we have 3y plus 1 equals to 12, okay, and we have 18. And the question says find x, Roman figure 2, find y, and Roman figure 3, find x plus y. Okay, let's do that. We're proceeding. Okay, now the first one says, since, please take note, 2x is not an element. It is 2x plus 4 that is an element. This 2x plus 4 is a single element of this matrix. Okay, do you get it? And this 12, since these two matrices are said to be equal, that shows this whole element will definitely be equals to 12. So therefore, my first question says, my 2x plus 4 will now be equivalent to 12. If you subtract 4 from both sides, you have your 2x to be equals to 12 minus 4. And your 2x is equivalent to what? What will be the value of your 2x? Your 2x will be equivalent to 8. If you divide both sides by 2, you have your x to be equals to 4. Okay? And for the second question, we're told to find y. That shows that this whole one, everything here, will be equivalent to this. Do you get it? And that shows that my 3y plus 1 is equivalent to 18. That shows that if you subtract 1 from both sides, that shows my 3y will be equals to 18 minus 1. So my 3y is equivalent to 17. If you divide both sides by 3, your y equals to 17 divided by 3. Do you get it? And the third question says we should find x plus y. If we are finding x plus y, my x plus y will now be equivalent to, what is the value of my x? 4. And what's the value of my y? That is 17 over 3. If you find the xm, the LCM will be 3. And the LCM here, 1 and 3, that's 3. 3 times 4 will be what? Will be 12. Plus 3 in 3, that is 1. 1 times 17, that is 17. And your x plus 4, your x plus y will now be equivalent to 12 plus 12 will now be equals to 29 over 3. 29 divided by 3. Okay? Now, let me do one more example. Example 3. If you're given this matrix x squared 4, so x squared, we're given minus 1, we have 2, we have square root of y equivalent to, permit me to write so that it can contain the board. If we have example 3, we have x squared, we have minus 1, we have 3, we have y is equivalent to, we have, let's say we have 9, we have, sorry, let me make this one square root of y. We have 3, we have minus 1, we have, let's say we have, what can I use here? Let's say I have 9 here also. And we have to find x and y. This is a question. Okay, I've tried to form a question here. Okay, now, if you check this question, you observe that we have x squared, we have 9 here. In place of minus 1, we have minus 1. That is correct. That is the same. The same. Okay, that's good. We have 3 here, we have 3 here. Perfect, that's the same. That shows that when we have square root of y, they need to be equals to 9. Do you get it? Now, since we have that, that shows that my x squared will be equals to 9. So therefore, if you find the square root of both sides, my x will be equals to plus or minus square root of 9. And my x will now be equals to plus or minus 3. Somebody's asking me now, why am I putting plus or minus? Anytime when you find the square root of a number, it is either plus or minus. Somebody say, why? Because minus 3 squared will give us 9. And plus 3 squared will definitely give us 9. Minus squared is plus. 3 squared is also 9. Plus squared is plus. 3 squared is also 9. Do you get it? That's why most times you always put plus or minus. Okay? Now, let me solve the second one. That says square root of y will also be equal to 9. So therefore, my square root of y will now be equals to 9. Now it shows that if you square both sides, if you square both sides of the equations, you have your y to be equals to 9 squared. And that's equals to 81. Therefore, x equals to what? 9 and y equals to 81. Do you get it? Perfect. Now, and this is the equality of matrices. Now, in our coming classes, we still have many to discuss. We need to discuss types of matrices. We need to discuss determinant of a matrix, transpose of a matrix, inverse of a matrix. We need to discuss subtraction and addition of matrices, multiplication of matrices, and even how we can use matrices to solve simultaneous equations. I know you can't wait to learn more about matrices. And in our coming classes, we're going to be dealing with this. Kindly subscribe to the channel and like my videos. Thank you so much. Bye.